Our next step is the discussion about the common pathway. Over here, you're looking at the common pathway, right? And ultimately, the extrinsic and the intrinsic pathway gets up into the common pathway, right? And over here, you just look out to see that they start eventually activating this factor 10, and we do have the activation from the both of the pathways to this factor 10a, right? And what is being ongoing now further one, right? This factor 10a, it starts working with the factor 5a, right? To convert, okay? This is factor 2, to convert, which is to be also known as the prothrombin. Now this is factor 2, which is also to be known as prothrombin, into the factor 2a. The name is thrombin now, right? So the factor 2, also to be known as prothrombin, and the factor 2a is actually the thrombin, right? And what is the role of the thrombin? This is important to understand. What is the main role, right? This thrombin activates the fibrinogen. This thrombin activates the fibrinogen, which is the factor 1, right? And so ultimately into the fibrin monomers, okay, which are the factor 1a, okay, to be considered of like that one. Then this factor, which is being over here, right, that is the factor 8a, starts stabilizing all of that fibrin and forming a fibrin mesh, right? This factor 8a start forming the fibrins, right? Which is start making out the strong fibrin mesh, right? So the common pathway travels from the factor 10, then to the factor 5, then to the factor 2, then to factor 1. And so, okay, sorry, this is not factor 8, this is actually factor 13. Yeah, my mistake. So factor 13 and ultimately the factor 13, right? And so this 13a helps out to stabilize all of that factor, right? And both of the roles are being done by the thrombin. If we do not have the production of the thrombin very well, if the thrombin cannot get activated, right? So this all of the stabilization of that primary platelet plug, or the formation of the, or the stabilization of the fibrin mesh cannot get happen out, right? So you have to remember it out very much carefully. So now you have to remember it out one thing, that this thrombin, like the key highlight point, that the thrombin, it makes out the fibrin, right? And the factor 13 stabilizes that one, right? The factor 13 makes out the stabilizing measure. Okay, so now let's pause for a curious clinical question over here, right? Why do we care so much about the thrombin? So you have to understand by looking out to this specific point that thrombin is going to be the central amplifier of the clotting now, right? It is converting the fibrinogens into the fibrin and activating one of the factor 13 too, right? And also starts helping activate other coagulation factors. So if we block thrombin, we strongly reduce the clot formation, right? If we stop this, we strongly reduce the clot formation. And so this is why you see that this effect showing up, that the thrombin is being now reduced, right, by the anticoagulants, by the some of the anticoagulants that you're looking at out. So the drugs like the dabigatran or the argatroban or the bivalirudin, right, which you're looking out over here, right? So the anticoagulant specific factors, the argatroban, right, the bivalirudin, and the dabigatran, all of these ones to be considered as which stops or inhibits or which reduce the clot formations. Okay, and so let's look out to the right side of the diagram under the anticoagulants, right? They list out the direct thrombin inhibitors, right? The direct thrombin inhibitors, including all of these three ones, right? This is very high yield point, right? To remember it out. Now, this means that these drugs directly block the thrombin, and they ultimately, if they are stopping the thrombin, ultimately this is preventing the formation of the fibrin mesh. This must have to be understandable by everybody, right? So onto the left side, now they have also list out some of the anticoagulants that acts around the factor 10a. Now if we block the factor 10A, right? So we do also have some other of the anticoagulants which work on this one, right? And all of these ones, they do include some of this LMWH is the low molecular weight heparin, right? Yeah, heparin, the deltaprin and the enoxaparin that you're looking at over here. These are the low molecular weight, right? And so we do also have some of the other inhibitors, that is the Paxaban, right? And also we do guard the another one over here, which is the fondaparinux, right? All of these ones to be known as the direct inhibitors of the factor 10A, right? So these all drugs, they do reduce the clot formation by interfering with the factor 10A activity, or we can just simply say the thrombin activity, because if we do not have the factor 10A, we do not have the formation of the factor 2A activity, right? So this is important to remember it out there, which are some of the drugs which do work out like that one, right? So now, after all this one, you have to remember it out that all of these which you are looking at out with the stars, right? All these factors, this is now another key point that we are going to do. All of these ones are dependent on vitamin K. All of these ones are dependent, all these factors are dependent on the vitamin K, right? Means that the factor 2, the factor 7, or the factor 9, the factor 10, right? All of these ones ultimately are the vitamin K dependent. And so this is clinically very, very important, because the warfarin inhibits the vitamin K recycling, so it affects these factors too, right? The warfarin and the heparins, we will get into the details. Okay, warfarin. Do remember this name, and I'm going to connect all of this one to our upcoming following